Okay, so today I want to talk about section 5.2 and 5.3 today. The section 5.2 is volumes. This is like outline. So I want to talk about how we can find the volume. Second one, I can explain about disk and washer methods. Third one, I will give examples by using disk and washer methods. So what's like a cylinder, or more precisely, a right cylinder is bounded by a plane, region B1 called the base, and the congruent region B2 in a parallel plane. The area of the base equals A. The height of the cylinder equals H. What is the volume of the cylinder? Like this. The volume is the area base times height h. This is like an example. So here, we have the P1 and B2. This one like base. We have congruent region B2 and B1. What's like volume? The area of B1, the area of B1. B1, so this area is like H. So area of base times height H. This is exactly the area. This is volume. So another one here, just one example. Was it like this circular cylinder? The volume is VR scale H because the area of circle here, the area of circle, the base, this area of circle, the base. This area is exactly pi times r square. So we can plug this value into here, exactly the pi r square times h. So this is rectangular box V. It's like another cylinder. What's that? Same. The area of base. The area base is the length times width, like LW, L times W. You can plug this one into the here. So we have the LW times H. So this is like volume of basic cylinder. So how to find the volume of a solid S? S is any solid. So this is the idea. For solid S that isn't a cylinder, we cut S into pieces. Next step, approximate each piece by a cylinder. Next, add the volume of the cylinders. Last one, you can use a limit process. This is the whole idea. So we have first step. What's step one? We cut S into pieces. This is step one. The approximate each piece by cylinder. This is like second step. The third step is you can add all approximate cylinder. Step 3. The step 4 is limit process. This is like 4 steps. We use these methods. The first one, intersect solid S with a plane PX, the perpendicular to the x-axis and passing through the point X. Obtain a plane region called a cross-section of S. The area of the cross-section of S in the plane PX is AX. So what does it mean? So like this. So we have the one solid. We have one solid is given. This is a solid. S is given. You can choose X. You have to cut by using plane. So passing through point X. So we have color like this way. So we have this kind of region on solid. So we call this region is cross section. This area is we use AX. This is like idea. So I can just show the graph. This is very clear, is right? Solid S is given. You have to cut this solid perpendicular to the x-axis. PX is perpendicular to the x-axis. So we have one plane region that we call cross section. This red one is cross section. The area of red one is AX. So we call cross sectional area, AX. This is the idea. So next tip. So how can you find exact volume of this one? You have to cut. Divide S into n slabs of equal width delta x by using the plane px1, px2, and so on to slide the solid. So think about slicing a loaf of bread. So what does it mean? Here, you have to cut. Here, you have to cut by using 1 point, second, third, the first one. You have to cut. We have the one part is the like here. So we can cut second part. This one. You cut more here. You can cut, choose more points. You have to cut. You can cut like this. Right? You can cut all points here. Step 2, choose a sample point xi star in xi minus 1 and xi and get the cross-sectional area of S at xi star. We call AXI star. Approximate the ice slab SI by a cylinder with a base area xi star. So like this one. You can cut here. This is xi minus 1. This is like xi here. This is xi minus 1 xi. You can cut like this. The next choose xi star. You have to cut. You have to cut by using cross section. This red one is like AXI star. This red one is AXI star. Next approximate ice slab SI by cylinder with base area AXI star. So what's the volume of this cylinder? We can use volume equals the area base times the height at the h. So here, AXI star. This AXI star is, this is a base. We have base, this is red one. This base is exactly AX star times delta x is height. Was it like height? This one. This is height, right? This is delta x. Step 3, add the volume of these slabs. The summation from I equal to 1 to n, AXI star times delta x. You can add it, all things. Next here, we define the volume as the limit of these sums as n approaches infinity, because this is approximate value, right? This is approximate value, not exact volume of a solid. Exact volume of a solid is this one, is right? This whole thing. So only this part is like approximate volume. So how can you sum the element of error? You can take limit of these sums as n approaches infinity, to take limit. So limit n approaches infinity, summation from I equal to 1 to n, AXI star times delta x. So you can change this one to the definite integral. The limit and summation is exactly same to what? integral from A to B. This is AX. So delta X change dx. That's it. This is the whole idea. So like this, where S is a solid that lies between X equals A and X equals B. The AX is the cross-sectional area of S in the plane PX through X and perpendicular to the x-axis. That's it. This is the whole idea for finding volume. So I can show previous one. How can you find the volume here? This one. So this is the idea. Can you erase this whole part? Here, the solid S is given. Here, the solid S is given. How can you find the volume of this one? The volume is exactly same to integral from here, starting point A to B. Times we have cross section AX, the cross section AX here, dx. That's it. This is the whole idea for finding volume of a solid. Was like AX? This is cross sectional area. This is a cross sectional area. Solid S. Okay, this is idea. So this is like a problem. Show that the volume of a sphere of radius R is volume V equals 4/3 pi R cubed. Now, how can you show this kind of things? Somewhat not difficult. But here, we can draw one sphere. We can draw one sphere. We can draw one sphere. This one, you can cut. Here, x-axis. This one is y-axis. This one. Was it like this point? This is like a 0. This is R. This is negative R. So we have the radius is R. This is the reason. This is like a 0. So how can you find the volume? So you have to choose point X. Point X was like X. X is between negative R and R. You can choose next. You have to cut this solid by using one plane. This plane is perpendicular to the x-axis. So one more thing is passing through X. You have to cut. So what happens? We have cross section. Here we have cross section. So like this, we have a cross section. So this is circle, that's right. This is circle. So this is AX. This one is AX. This is AX. Was like exact volume. The volume is, you can use formula. Integral from starting point negative R. Terminal point R. A of X dx. This is idea. So one more. Was it like AX? AX is circle of this. This is like area of this circle, the cross section. So what's like AX? I can draw this part again here. So we have like a circle, is right? So this cross section is exactly circle. This one. You can choose center. What is radius? Do you know what is radius? Do you know what is radius? So could you write your answer? What is radius? Here, this point is like x, exactly this one. This one is x. This is like radius. What's like this radius? This one. So do you have any idea? Pi r squared. Yeah, you're right. Pi r squared, not r. So, you know, the r is here. This r is this one. So let me see. You can use make a triangle, this one and this one. Make a triangle like this. So what is this one? This is x, is right? This is x. What is this one? This is r. Is r. So what is opposite? This opposite is you have to use Pythagorean theorem. The r square, hypotenuse square minus adjacent square and take a square root. Is right? You can use Pythagorean theorem. The square root of r square minus x square is exactly radius. This radius is square root of r square. You're right. The y value r square minus x square. So we can write this is y. Yes. So what is AX? The area is, you said, pi times radius squared. The pi times radius square root of r square minus x square squared. The square root is gone, just pi times the r square minus x square. So that's it. This is like AX. You plug this one into here. So we have integral from negative r to r. AX is pi times the r square minus x square dx. So you can calculate. You can keep pi. What is integral r squared? What's integral r squared? Do you have any idea? What's integral r squared? What is integral r squared? So could you write your answer on chatting board, please? No, not derivative, integral. So my question is, what's integral r squared? The integral r squared dx, not derivative. Here, what's that? So do you know this one? What's integral 3dx? What's that? Do you know what integral 3dx? Integral 3dx is, so we have the 3x plus c. We have 3x. So this one is r squared is like constant because x is a variable, exactly r squared x. So we have r squared times x minus what is integral x squared? What's integral x squared? Do you know integral x squared? What's that? So do you have any idea what is integral x squared dx? The integral x squared dx is, do you know some of the power rule, the next one? 1 over 2 plus 1 x to the 2 plus 1, the next one. So we have 1/3 x cubed. the x is variable. The r is like constant, x is variable. We can use power rule from negative r to r. So you have to simplify. Pi times you plug r cubed minus plug r 1/3 r cubed is the first one, minus plug minus r into x, r squared times negative r minus, you have to keep this one, minus 1/3 negative r cubed. Can use close this portion. So same to pi. The r cubed minus 1/3 r cubed is 2/3 r cubed. Here, negative was like inside one, negative r cubed. The minus r cubed is negative r cubed. Take out negative one. Negative times negative is positive. So 1/3 r cubed. This is same to pi times 2/3 r cubed minus the negative r cubed plus 1/3 r cubed is negative 2/3 r cubed. So we have pi times, you can change it, this one to the positive. So 2/3 plus 2/3 is 4/3 r cubed. You have to interchange pi and 4/3. So 4/3 pi times r cubed. This is whole idea for solving this problem. Yes, we have this result. So like this. Right? This one. The next tip. Find the volume of a solid obtained by rotating about the x-axis the region under the curve y equals square root of x from 0 to 1. So what's that? Here, this is idea. So we have same. You can sketch the graph y equals square root of x. Y equals square root of x is from here. Graph is like this from 0 to 1. Just 0 to 1. This is y equals square root of x. So we have this region like this. The next, you have to rotate this region about x-axis. You have to rotate this region about x-axis. You have to rotate about this region. So we have this is solid. You have to rotate, we have like this. This one. So this is 1. This is like 0. So we have it. Solid. How can you find the volume of a solid? Same thing. You can use volume V is integral from A to B. The cross-sectional area dx. You can use formula. So from here, what is A? A is here, 0 to 1. So we have it. This one. How can you decide AX? The same. You can choose any point X between 0 and 1. I can choose X is here. So next, so you have to cut this solid by using one plane. This plane is perpendicular to the x-axis and passing through x. So we have this one. we have this kind of a circle. So like a circle, we have this region. So how can you find this AX? This is like AX. So this AX is exactly circle, is right? We have like disk and circle. I want to find radius of a circle. What's it like radius? Here. This is like a center. Radius is this one, this length. What's it like this length? You have to go into this point. This is like x. So this length is exactly same to this one. This length is right. This is like radius. What's that? You can plug x into here. We have y value. This y value is this one, square root of x. The square root of x is radius. This one. Next, find area of this one. The area is ax. Ax is square root of x pi times radius squared. The square root is gone, pi x. So we have it. So plug into here. We have pi x dx. The next, find antiderivative. You keep coefficient pi. The integral x is 1 over 2x squared from 0 to 1. So we have pi over 2 times 1 squared minus pi over 2 times 0 squared. 0 squared is like 0. Final answer is pi over 2. So that's it. This is the whole idea for finding volume of a solid. Now always use the cross section. This is like a key. So we have it like this. This one. Like this. The next one. Find the volume of a solid obtained by rotating the region bounded by y equals x cubed, y equals 8, and x equals 0 about the y-axis. So how can you find? The same. First, you can draw region. The region, what's it like region? The region is like this. Y equals x cubed. We can draw y equals x cubed first. Y equals x cubed is, graph is like this. This one and this one. So y equals x cubed. Y equals 8 is here, 0.8. You have to cut y equals 8. This one. X equal to 0. X equal to 0 is exactly same to y-axis. So what's this one? We have this region. This region. You need to find this kind of things. So like this. Next, so rotate this region about y-axis. You have to rotate about y-axis. So what kind of solid do we have? Do we have like this? We have solid. This one. Here. Like this. From 0 to 8. So in this case, how can you define the cross section? We use not x. You have to choose x value here. You have to cut this solid by using the perpendicular plane. So we have cross section is here. We can cut. What's the cross section? So we have like this kind of things, right? You can cut here, we can cut, we have here, this one, and like this. Very awkward one. The very awkward one, like this. It's not good. It's not good. This is not good. So what's like the best way in this case? So cross section is not this one. So don't use this one. The cross section is this is better. So don't choose X in this case. Only choose Y value. And cut. You have to cut this solid by using horizontal plane passing through Y. So we have, this is a cross section. The cross section is also circle passing through Y. This one, this is cross section. So cross section is exactly circle, like a circle. You can choose point here, what's it like radius. So this is what? Y value. The radius is, this is the radius of a circle. This one. We are going back to here. Choose Y. This value is, this segment, length of the segment is exactly radius. So what's that? Here. X value. What's like X value? You can change it. This function is Y equals X cubed. You have to solve this equation for X. You can take a cube root of both sides. X equals cube root of Y. Is right? So like this. So here, Y equals X cubed is given. You can take a cube root of both sides. Cube root of both sides. So we have the X equals cube root of Y. So this value is cube root of Y. So like this. So cube root of Y. So what's like area? This area is like pi times radius cube root of Y squared. So we have pi times, this is Y to the 1/3. Square is pi times Y to the 2/3. This is like area. What's like volume? So we can use another rule. Integral from what's starting point 0 to 8. We have Y value changed. The cross-sectional area is A of Y. Y is variable and dy. So we have integral from 0 to 8. A of Y is this one. Pi times Y to the 2/3 dy. Right? This is whole idea for solving this problem. You can define antiderivative. Pi, the integral Y to 2/3 is use power rule 1 over 2/3 plus 1 Y to the 2/3 plus 1 from 0 to 8. So what's that? Pi times the 1 over the 2/3 plus 1 is 5/3. Flip 3 over 5. The Y to the 5/3 from 0 to 8. Next, plug these numbers. Pi times 3 over 5 times A to the 5/3 minus pi times 3 over 5 times 0 to the 5/3. It's like a 0. So we have only here. We can simplify. Pi times 3 over 5 was like 8. 8 is 2 cubed. 2 cubed to the power 5/3. 3 is crossed out. Only 2 to the 5. Pi times 3 over 5 times 2 to the 5 is the 32. The 3 times 32 is 96. So final answer is pi times 96 over 5. You have to interchange 96 over 5 pi. This is final answer for solving this problem. So like this. The next one. Find the volume of the solid obtaining by rotating region enclosed by the curve y equals x and y equals x squared about the x-axis. So, similar. So how can you find exact volume of this question? So same. You can draw one curve and one line. Here, y equals x first. You can draw y equals x. So y equals x. This one. Next, y equals x squared. The next one, y equals x squared is bottom one. So what's that? You can find intersection point here. What's like intersection point? You solve. X squared equals x. You solve this one. Subtract x from both sides. X squared minus x equal to 0. Factor out x. X minus 1 equal to 0. What is x? X is 0 and 1. So we have this is 0, this is 1. We have it. We have this region. So what's that? This is y equals x. The bottom one is y equals x squared. The next is the rotate this region about x-axis. You have to rotate about x-axis. This one. So what happens? We have this one. You have to rotate. So you can rotate this one. So we have cone here. In the rotate this one, we have cone. Cone. You can rotate this inside one. We have tornado, like tornado. Like this, right? So this is from 0 to 1. 0 to 1. So next tip. So you have to cut this solid. You can cut this solid passing through this x value, passing through x value. So what's that? You have to cut by using vertical plane. We have outside has one big circle. Outside has one big circle. So like this, one big circle. The inside one has like a small circle. Like this, is right? So what happens? You can draw this cross section in here. You can draw this cross section in here. So what's that? We have bigger one and small one. So we have this area. That's right. Between two circles, you can find this area. This one. So how can you find this volume? You can find here outer radius. You can find outer radius. You can find inner radius. Inner radius. You can find outer radius, inner radius. What's like outer radius? Here, This is center. The outer radius is, you only cut the next way. This is outer radius. This is outer radius. Here. You can then move x value here. So outer radius is this one. So what's that? Y value is also x. It's x. So outer radius is x. What's like inner radius? This one, from here to here. What's like inner radius of this one? The inside one is only this portion. So we have y value here. Y equals x squared. This is x squared. So x squared is inner radius. So what's it like area of AX of cross section? The pi times outer radius is pi times outer radius squared minus pi times inner radius squared. So we have factor of pi, the outer radius squared minus inner radius squared. Outer squared minus inner squared. This one, you can plug. Pi times outer radius is x, plug into here, just x squared. The inner radius is x squared, plug into here, x squared squared. So we have pi times x squared minus x to the 4. So we have it. So what's it like a volume? The volume is, you can use formula. Integral from a to b, a of x dx. What's that? You see integral was a 0. Was b 1. The ax is, we have it, pi times x squared minus x to the 4. This one, and calculate. So what's that? This is pi times. Integral x squared is 1 over 3 x cubed minus integral x to the 4 is 1 over 5 x to the 5 from 0 to 1. You plug 1 pi times 1/3 times 1 cube minus 1 over 5 times 1 to the 5. You plug 0, all things 0, you don't need it. Only calculate. The 1/3 minus 1 over 5 is like 2 over 15. Answer is 2 over 15 pi. This is whole idea for solving this problem. So like this. Right? So we have a name. So we call, this is what? Like a washer. So we call like a washer. So I wanna summarize. A solid of revolution is obtained by revolving a region about a line. The volume is integral from a to b, ax dx, or volume is integral c to d, ay dy. So we have two kinds of cross section. The first cross section is only disk, is right? Remember the previous one, not this one. Here, right? Or not this one. So here, this kind of problem, we have disk. So we have a disk. The second one is like a washer. This one is a washer. So the cross section is a disk. So find the radius of disk in terms of x or y, depending on which equation do you want to use. You can use this one, in terms of x, This one in terms of depending on. So was it like area A? The area of disk is area of circle. The pi times radius squared. The second one is the cross section is a washer. Was it like a washer? Find the inner radius R in, outer radius R out. So was it like area? Pi times outer radius squared minus inner radius squared. This is exactly the area of cross section. So we have two kinds of cross sections. Okay. So far, do you have any question with these problems? So if you don't have it, so we are going to the next problem here. Find the volume of the solid obtained by rotating the region enclosed by the curve y equals x, y equals x squared about the line y equals 2. Y equals 2. So we have this one. The same. You can sketch the graph, the y equals x, y equals x squared is like parabola. This one, y equals x squared. Find intersection point. How can you find the intersection point? You can solve x squared equals x. Subtract x, x squared minus x equal to 0. Factor out x. We have two x values. X is 0 and 1. We have 0 and 1. We have this region. Right? You have to rotate this region about y equal to 2 here. You have to rotate this region about y equal to 2. You can rotate like this. It's good. So what kind of solid do we have? Here, do we have this kind of things? So you have to rotate about y equals to 2. Do we have this one? Here. This one. So we have y equals to 2 here. Y equals to 2. We have outside one is this one, this curve. So like this. So we have here y equals to 2. We have this solid. This one, we have this kind of solid. So inside one has this one. Inside one is like this. This one. So what's that? This is from 0 to 1. The next tip. You can make a cross section. How can you make a cross section? Same. You can choose point X. You have to cut this one. Cut by using the vertical plane, the perpendicular to the x-axis. You can cut. So outside has like one big circle. Outside has one big circle. Inside one has like a small circle. The inside one has one small circle. So what's that? This is washer. So we have washer. So we have like this one. Here and small one. We can find outer radius and inner radius. What's like outer radius? Here. You can choose center. The center of circle is on the rotating axis 2. Outer radius is this one. This bigger one. So what does it mean? You can choose x value here. So center of circle is here. You can connect to like this way. So this length is exactly outer radius. So what's that? This is function value. This is x squared. What is this length? From here to here. What's the length of outer radius? Could you write your answer? What's the outer radius? Here, here, 2 x squared 2 to the 2 here. What is this outer radius? So do you have any idea? What is outer radius? This one? From here to here? What's that? Exactly the 2 minus x squared. So we have this length from here to here, exactly 2 minus x squared. What is inner radius? Inner radius is from here to here, here to here, the exactly center to this one. This is the on the line y equals x. This is x. Inner radius is this length. It's inner radius, exactly 2 minus x. We have 2 minus x. So what is ax? Pi times outer radius squared. 2 minus x squared minus inner radius squared 2 minus x squared. So we have it. What's like volume? The volume is integral from A to B. A is 0, B is 1. The 0, 1, AX dx. What's AX? So we have it here. Pi times outer radius squared, 2 minus x squared minus 2 minus x squared dx. So we have it, right? This is the whole idea. So, and calculate. So we have this one, so like this, we have it. This one. So next is simplify. 2 minus x squared is the 4 minus x squared, 4x squared plus x to the 4. The 2 minus x squared is exactly 4 minus 4x plus x squared. And simplify here. Distribute negative. 4 is cancelled. X to 4 in here. So this is change positive, right? And this is same to what? Remaining part is the negative 4x squared plus x to the 4 plus 4x negative x squared. So we have x to the 4. The minus 4x squared minus x squared is negative 5x squared. The remaining part is plus 4x. So we have it here. Next, find antiderivative. Antiderivative is the integral x to the 5, x to the 4. So what is it, integral x to the 4? Do you know what's integral x to the 4? So do you know? If you know this answer, could you write your answer on the chatting board, please? Yeah, 105 x to the 5. What is integral x squared? Integral x squared is the same. The 1/3, yeah, good. 1/3 x cubed. Integral x is 1/2x squared. So we have it. You plug 1 and 0, we have this result. You plug 1 into x, exactly 1/5. 5 times 1/3 is 5/3. 4 times 1/2 is only 2. You plug 0 into x, exactly 0. So we have this kind of things. The simplify, we have 8 pi over 15. This is whole idea for solving this kind of problems. So here, find the volume of a solid obtained by rotating the region enclosed by the curve y equals x and y equals x squared. We have same curve here. The same curve. What's it like curve? Curve is the same. So we have y equals x, y equals x squared. The intersection point is 0 and 1 is same. We have this region. You have to rotate about x equals -1. X equals -1. You have to rotate about x equals -1. So what kind of solid do we have it? So we have this solid. So we have here, this is rotating axis. This is -1. So we have here, this one. We have solid. Bottom one has small solid, small circle, like this. Next to inside one. This inside one has like this one. So in this case, don't cut this solid by using vertical plane. So we don't have circle things here. We can use y value. You plug one into here or here, y value is always 1. So what does it mean? From 0 to 1. You can choose y value is better and cut this solid by using horizontal plane. So what happens? You can use horizontal plane. We have this cross section. Inside one has like a big circle. So inside one has like a small circle. We have small circle. So like this, we have washer. What's that? Here we have washer. We have washer. The same. Outer radius, inner radius. How can you find the outer radius? Here. The center of the circle is x equals -1. The outer radius is this one. So from here, this one is outer radius. So what does it mean? You can choose y value here. The center of the circle is on the rotating axis. So this length. So this length is exactly outer radius. What's that? This is x value. What's that? This one is y equals x squared. Take a square root from both sides. X equals the square root of y. We have square root of y. So what is outer radius? From here to here. What's that? This length is 1. Here, this length is 1. This length is square root of y. So we have 1 plus square root of y is exactly outer radius. This one. The next inner radius. Inner radius is from the center to this one, this length here. So what's that? We have point. So this line is y equals x, x is y. X is y value. So what is inner radius from here to here? Same. This length is 1. This length is y. You add 1 plus y. This length is 1 plus y. So we have it. The next, find A of y. Cross-section area, what's that? Pi times outer radius, 1 plus square root of y squared, minus 1 plus y squared. So what's like a volume? Volume is integral from, in this case, like 0 to 1. Only y value change it, 0 to 1, y value change it. AY is pi times the 1 plus the square root of y squared minus 1 plus y squared dy, and calculate. This is whole idea like this. This one, and calculate. The simplify. The 1 plus here, the 1 plus square root of y squared is this one. The 1 plus y squared and take negative, we have it, and simplify. So 2 square root of y minus negative 2y is minus y squared, 1 is cancelled. So we can change square root of y to the 1 half. You can use power rule, 2 times 1 over 2 plus 1, y to the 1 over 2 plus 1 minus y squared over 2 minus y cube over 3. The simplified form is like this. Plug 1 and 0, we have it, and simplify. This is answer, the pi over 2. This is the whole idea for solving volume problems. Okay, so this is like the volume. It's good. So far, do you have any question? No, you don't have a question? Okay, the next one. So we are going to the cylindrical shell. Here, the next one, section 5.3, the volumes by cylindrical shells. So what's that? So we have the like this. This is our line. How to find the volume by cylindrical shells. The second one, give examples. The third one, how to choose the previous section, disk method or washer method or method of cylindrical shells. How can decide? The next, I will give examples. So like section 5.3. So some volume problems are very difficult to handle by the methods of the preceding section, like the disk method or washer method. Sometimes very difficult. I can give one example. Find the volume of the solid obtained by rotating the region bounded by y equals 2x squared minus x cubed and y equals 0 about the y-axis. So let me see. here. So first, you can sketch the graph. This one. So you can do factor x squared 2 minus x. So what's it like x-intercept? How can you find the x-intercept? X-intercept is x squared 2 minus x equal to 0. You plug 0 into y, so x value is 0 and 2. We have 2 points. What's it like a graph? The graph is like this. Here, so we have 0 and 2. 0 and 2. This is x-intercept. So what's that? 2 minus x is power 1. What does it mean? Cross. The x has like power 2, only touch. Graph is the like this one. So one more, y equal to 0. Y equal to 0 is this one. We have this reason. You have to rotate about y-axis. So what happens? This is like solid. Solid is like this. This outside one, this one is here. Like this. This is bottom one. Inside one has the like this, is right? This one. So how can you solve? You have to cut. This is y value and cut. We have washer. Outside has big circle. Inside has small circle, like washer. So how can you do that? You can cut here. Outer radius is from here to here. This is outer radius. This one. So from here to here, we have inner radius. Outer radius, inner radius of washer. How can you find outer radius? You can just solve this equation for x. Function is given. You have to solve this equation for x equaled g of y form. How can you solve? Y equals 2x squared minus x cubed. Do you know how can you solve x equal to g of y form from the y equals to 2x squared minus x cubed? Do you know? So what do you think? The y equals 2x squared minus x cubed is given. You can solve this equation for g of y form like this. So what do you think? So do you know? How can you solve like this? They're not easy. They're really difficult. They're really difficult. So what does it mean? So we can compute inner radius and outer radius of the washer. We have to solve the cubic equation y equals to 2x squared minus x cubed for x in terms of y. It is difficult. So we cannot use the washer method. How can we solve this problem? We have one easier method. Today's topic, the method of cylindrical shells. This is like I. So I want somebody let me know what is cylindrical shells method. Here we have cylindrical shell is given like this. Was like R1 inner radius, right? Here the inner radius R1. R2 is outer radius here. R2 is outer radius. The was like H height. is height. This one. What's R? R is only, this is a midpoint here. This is R, right? The center from this midpoint of R1 and R2. This midpoint, R1 plus R2 over 2. So we call the average radius of the shell. What's delta R? Thickness here, is right? The thickness delta R is R2 minus R1. Outer radius minus inner radius is delta R. So we call the thickness of the shell. What's like V2? The volume of outer cylinder. The V1 is volume of inner cylinder. So we have it. What's like the volume of a cylindrical shell? So we can use next one. Outer cylinder minus inner cylinder. How can you find the outer cylinder? So do you know what's like volume of a cylinder? Do you know that? This one? So here I can give one example. So we have cylinder. The circular cylinder is given. So like this. H is height, radius is R. What's the volume? Do you know volume of a cylinder? So could you write your answer on the chatting board, please? What is the volume of a cylinder? What's like area of a circle? The base? What's the area of a circle? The area of a circle is, yes, pi r squared times height h. This one, pi r squared times h. So what's it like V2? So exactly pi. What's it like outer radius? R2. R2 is outer radius. R2 squared times h. Minus, what's V1? The inner radius R1. So we have pi times R1 squared times h. We have it. The next, factor out pi and h. Factor out pi, factor out h. So we have it. Next, factor. R2 squared minus R1 squared is R2 plus 1 times R2 minus 1. So next, change a little bit here. R2 plus 1, you can change it 2 times R2 plus 1 over 2. You can change it like this. Next, take out 2 here. And pi. Was it like R2 plus or R1 over 2? We have R. We can replace. This is R. The R2 minus R1 is, we have thickness, delta R. The H is here. We have 2 pi R delta R times H. So what is 2 pi R? The 2 pi R is circumference. Delta R is the thickness. H is height. We can interchange it. We have it. 2 pi R times H times the delta R. What is 2 pi R? 2 pi R is circumference, is right? We have a circle is like one, length is R. What's like a circumference? The circumference is 2 pi R. The H is height. The delta R is thickness. Here, the thickness, we have this one. This is a formula. The circumference times height times thickness. So we have it, the volume of the cylindrical shell. The next tip, let S be a solid obtained by rotating about the y-axis. The region bounded by y equals f of x, where f of x is greater than y equal to 0. Y is 0, x equals a, and x equals b. So where b is greater than a, so a is greater than y equal to 0. So we have this one. You have to rotate about y-axis. So we have this kind of solid, right? Like this. How can you find? So we can use these steps. Step 1, divide interval AB into n sub-intervals x0, x1, x1, x2, xn minus 1, xn of equal with delta x equals b minus a of n. Next, choose a sample point xi star. Xi star is xi minus 1 plus xi over 2. Is it right? So what does it mean? Just here, cut like this. Like this. This is x0, x1, x2, keep going. Last one is xn. And cut. Cut like this. This one. So we think about this point is xi minus 1. This point is xi. You can choose xi star is midpoint. You can choose midpoint. This is what? Xi star. Xi star. So like this. The next one. You can make a rectangle here. Make n rectangles with base delta x, height f of xi star, and rotate each rectangle about y-axis. So what does it mean? Here. I just said before, you can call like this way. We have xi minus 1, xi, choose midpoint xi star. How can you make rectangle? You have to use xi star. You have to cut, what's that? This is function value f of xi star. This is height, make rectangle. This one. Next, you have to rotate this rectangle about y-axis. You have to rotate this rectangle about y-axis. What happens? Rotate this rectangle about y-axis. So we have one cylinder, is right? The outside has this one. Inside one is like this. We have cylindrical shell. This one. What's that? This is x, I. So this one is x, I minus 1. What's the midpoint? The midpoint is xi star. This is xi star. What is height? Height is f of xi star. So we have this kind of things. It's good. So like this. This is here. This one. So we have n cylindrical shells with average radius is xi star and height is f of xi star. This is like f of x bar. So we can change it. This is what? The midpoint is xi star. This one. The thickness is delta x. So what's like a volume of a cylindrical shell? You can go into previous one. The volume of ith cylindrical shell is the 2 pi xi star times f of xi star times delta x. Step 3. The approximate the volume of S by sum of the volume of these shells. So we can add it. We can add it. The all volumes of these shells. So this meaning, like this, add it. The next is, this is like approximate value. How can you find the exact volume? You can take a limit. So this approximation appears to become better as n approaches infinity. Was like exact volume of solid. The limit n approaches infinity, summation from I equals 1 to n, 2 pi xi star times f of xi star times delta x. So you can change it definite integral. So what's that? Limit and summation is going to integral from a to b. The 2 pi xi star is going to 2 pi x. F of xi star is going to f of x. delta x is going to dx. That's it. This is the idea. So we have integral from a to b 2 pi x f of x dx. Was it like this kind of things here? Was it like x and the f of x rule? We have 2 pi times radius times height. This is like the best way. So what does it mean? So why this is true? So let me see. The previous one has this kind of a region. This is like x. You have it make a rectangle. You have to rotate this rectangle. We have what? Cylindrical shell. This is like point x. So radius of cylindrical shell is, this length is x. The load of x is radius. And f of x is height of cylinder. This is f of x is the height of cylinder. We use height. So this is like the best way. You can memorize integral from a to b, 2 pi times radius times height. This is whole idea for solving this kind of problem. You can apply this method to our previous example. So how can you find the answer? So like this. Here, was it like a graphic? The graph is like this from the previous one, from 0 to 2. So we have it, so this region. So how can you use our result? What was our result? Integral from a to b, so 2 pi times radius times height dx. How can you use here? You can choose x value. You can find this one. You can cut rectangle. Make a rectangle. You have to rotate. We have rotate about y-axis. Rotate this rectangle about y-axis. We have one big circle here. This one. The inside one has small circle. The next one. We have small circle. We have rectangle. What does it mean? Like this. This one. So we have it. This is like a cylindrical shell. So you can use here. What's it like radius? The radius is, center is on the rotating axis from here to here. So midpoint, exactly x. X is radius. What's height? Height is function value. You plug x into on the curve, 2x squared minus x cubed is exactly height. Height is 2x squared minus x cubed. So that's it. And simplify. Distribute x. Next, find antiderivative. Plug 2 and 0. We have this result. Simplify. We have 16 over 5 pi. This is whole idea for solving this problem. It's good? So next one. Find the volume of the solid obtained by rotating the region bounded by y equals x minus x squared and y equals 0 about the x equals 2. So how can you solve this problem? Here, you can draw x minus x squared first. You can only factor out x. This one. Was it like x-intercept? The 0 and 1. You can find x-intercept. Just x times 1 minus x equal to 0. So x is 0 and 1. We have 2 x-intercepts. So was it like a graphic? Graph is a parabola. The coefficient of x squared is negative number. What does it mean? Open down. This is open down. So graph is like this. So we have 0 here. This one, 0 and 1. So y equal to 0 is here. What's that? We have this region. This region. You have to rotate this region about y equals to 2. Y equals 2. This is 2. So how can solve this problem? You can use this one. Here, you can choose x value. You can make a rectangle. The same, you can make a rectangle. How can you make a rectangle? Rectangle is like this. You can make a rectangle. You have to rotate this rectangle about y equals to 2. You have to rotate this rectangle, y equals to 2. What's that? We have cylindrical shell. We have cylindrical shell. So you need to find the average radius. What's like average radius? Here, the center of circle on the rotating axis. This is this point here. Connect to this point. We have this length is like radius. What's that? Exactly 2 minus x is right. The 2 minus x is radius. So one more was height. Height is this one. You can plug x into curve. So the function value of curve is x minus x squared. We have x minus x squared. What's it like volume? You can use formula. Integral from a to b. What's that? The 2 pi times radius times height. dx. What's that? Integral from here, 0 to 1. So 2 pi times what's the radius? Radius is 2 minus x. Height is x minus x squared. Like this. So we have it. So next, calculate. The calculation is up to you. So like this. So we have it. The pivot. The key part is here. What's that? The radius is 2 minus x. Height is x minus x squared. This is the key for solving this problem. Okay, this is like idea. The next one. I want to summarize. So when do you decide the disk, washer, and cylindrical shell? How can you decide that this kind of method? So here, find the volume of a solid obtained by rotating the region bounded by y equals f of x, y equals to g of x, x equals a, x equals b, about a specified line. Case 1, the rotating axis is horizontal line. The rotating axis is horizontal line. What's that? Use disk or washer method. This is easy one. So the cross section is a disk. The AX is pi times radius squared. The cross section is a washer. The AX equals pi times outer radius squared minus inner radius squared. The volume is integral from A to B. the cross-sectional area dx. The second case, rotating axis is vertical line. You can use method of cylindrical shell. What's volume? Integral from A to B, 2 pi times radius times height dx. This is whole idea. In this case is, what's that? F of x and g of x. The example is like this one. So we have, this is f of x, this is like g of x. This is A, this is B. So this area. You can rotate about x-axis, like a horizontal line, you have to use this method. Rotate about y-axis. Rotating axis is vertical line. We use cylindrical shells. This is a whole idea for solving this kind of problems. So I can give the more examples later. The next one, another one. Find the volume of the solid obtained by rotating the region bounded by x equals f of y, x equal to g of y, x equal to c, x equal to d. The g of y is less than y equal f of y, and c is less than y equal to d about a specified line. Case 1. The rotating axis is horizontal line. What's that? You can do the opposite. You can use method of cylindrical shells. Volume is integral from C to D, 2 pi radius times height dx. Second case, the rotating axis is vertical line. You can use disk or washer method. The cross section is a disk. AY equals pi times radius squared. The cross section is a washer. AY equals pi times outer radius squared minus inner radius squared. The volume is integral from C to D AY dy. What does it mean? The graph is like this. This one. This is x equals f of y. This one is left boundary, x equals g of y. This point is C. This point is like D. You can rotate this region about x-axis. What's that? We can use cylindrical shells. Rotate about y-axis, vertical line, we use disk or washer method. Right? This is the whole idea for solving these kind of problems. I'm going to give examples. Find the volume of the solid obtained by rotating the region enclosed by y equals 2x and y equals x squared about the x-axis. So what's that? You can draw graph. Y equals x squared is like this. Y equals x squared. So we have y equals 2x. Y equals x squared is this one. You can find intersection point. How can you find the intersection point? You solve. The 2x equals x squared. You subtract 2x from both sides. X squared minus 2x equal to 0. Just factor out x. What is x? X is 0 or 2. 0 or 2. So we have 2 and 0. So we have it, this region. This region. You have to rotate this region about x-axis. So you have to decide which method is better. The disk or washer method or the cylindrical shells. Which one do you want to choose? I can write here. So which one? Disk or washer method or cylindrical shells. Cylindrical shells. Which one? Could you write your answer on the chatting board? Which one? Disc or washer method or cylindrical shells method? Which one? Which method do you want to use for solving this problem? Disc or washer or cylindrical shells? Which one? So here, we are going back to previous one, but not this one. Here we have the y equals f of x, y equals g of x is given. The rotating axis is horizontal line. So we use disc-core washer. The vertical line, method of cylindrical shells. Here. So we can use disc or washer method. Washer method. So how can you make the disc and the washer? This is like idea. You have to choose X. You have to cut. We have this segment. You have to rotate this segment. Rotate this segment about x-axis. You have to rotate this segment about x-axis. So what happens? We have rotate our segment. We have one big circle. We have one small circle. The next one, we have washer. That's right. So was it like outer radius? Center is here. Outer radius is this one. This is outer radius. So this point is on the line. So we have here y equals 2x. We have 2x. The outer radius is 2x. Was it like inner radius? This one? Inner radius. Inner radius is point on the curve x square. This point is like x square. The inner radius is x square. So what's that? The volume V is integral from A to B. AX dx. So what's volume? Integral from 0 to 2, is right? The starting point is 0, ending point is like 2, 0 to 2. What's AX? Pi times outer radius squared. Outer radius is 2x minus inner radius x squared squared. So like this. Next, calculate. This is the whole idea. Here, like this. So we have it. Next problem, the same things. Like the same things. So what's that? So you can define intersection point, draw the graph, exactly same to previous example. We have x equal to 2x. So y equals x squared. We have 0 and 2. So what's that? So you have to rotate this region about y-axis. So rotating axis is vertical line. You have to use cylindrical shells method. Cylindrical shells. Cylindrical shells. How can you use cylindrical shells method? This is idea. You can choose X and cut. The same. You can make only rectangle. You have to rotate this rectangle about y-axis. You can rotate this rectangle about y-axis. We have washer. We have washer. This is washer. This one. You can choose center, find outer radius. So what's like a center? The center is always rotating axis, right here. This is rotating axis here. This one. You can connect to the midpoint of a rectangle. The midpoint of a rectangle is exactly same to x, is right? This radius is exactly x. So radius is x. What's like height? Height is this one. This is height. So exactly this function value on the line 2x. The function value on the curve is x squared. The height is exactly same to 2x minus x squared. So what's like volume? Volume is integral from A to B. The 2 pi times radius times height dx. You can use it. What's that? Integral from A is 2. A is 0, B is 2. We have 0 to 2. The 2 pi times. What's like radius? The radius is x. What's height? 2x minus x squared. So that's it. And solve. The calculation is up to you. So we have the 8 over 3 pi. This is idea. Next one. The same. The same. Only difference is like rotating axis is y equals -2. Y equals -2 is rotating axis. Here, the same. You can choose x. We have segment. This is black one, segment. You have to rotate this segment about y equals -2. Is right? You have to rotate this segment about y equals 2. What happens? We have big circle. So from here, this point has like a big circle. This point has small circle. We have washer. Washer. You can find outer radius, inner radius. So what's like a center? Center of washer is always on the rotating axis. What's like outer radius? You can connect this point to this one. You can connect this point to this one. This is outer radius. This is outer radius. What's that? This point is function value 2x. So what's that? 2x plus 2. We have 2x plus 2 is outer radius. What is inner radius? From here to this one. This length is inner radius from here to here. The inner radius, this one. What's like a function value? Function value is on the curve x squared. So we have x squared plus 2. So we have x squared plus 2. So 2 plus x squared. So what's like a volume? Same. Integral from A to B. A of x dx. So what's that? Integral A is 0 to 2 here. 0 to 2, intersection point 0 and 2. AX is pi times outer radius, the 2 plus 2x. Here minus inner radius, x squared plus 2 squared, the 2 plus x squared squared. X. This is the idea. The next one is solve. So we have 48 over 5. The next thing. You can rotate about x equals -2. How can you do that? Same graph. Only difference is x equals -2 is rotating axis. The rotating axis is vertical line. You can use cylindrical shells method. You can choose x here. You can make a rectangle. You have to rotate. This is rectangle about x equals -2. We have washer. Sorry, not washer. This is cylindrical shell. This one. And this one. So like this. You can find average radius. What's average radius? So here, this is midpoint. You can connect to the rotating axis. So this length is radius. What's that? This point is x, is right? So here, x plus 2. We have 2 plus x. The radius is 2 plus x. What's height? Height is this one. This is height. So this function value is on the blue line. Blue line is 2x. Red curve is x squared. Exactly this one. This one is 2x minus x squared. Like top on curve 2x minus bottom curve x squared. So what's it like volume? Volume is integral from A to B. What's it like cylindrical shells? The 2 pi times radius times height. Dx. So integral from same. Left hand point, right hand point, 0 and 2. 2 pi times radius is 2 plus x. So height is 2x minus x squared. So like this. And find the answer. The calculation is up to you. So like this. So next one. So we have same curve, same line. Only difference is rotating axis. So like this. Here, rotating axis is horizontal line. So what does it mean? You have to use washer or disk method. How can you do washer method? Same. You can choose X and make a segment. You can cut, you can make a segment. You have to rotate about y equals 6. You can rotate this segment about y equals 6. So what happens? We have washer. Washer. What is outer radius? What is inner radius? Here, this is like a point you can connect. So this segment to rotating axis. So you can connect this segment. So what's that? This is longer one. The longest one is exactly outer radius. What's that? This function value is x squared. So what's that? What's it like radius? The 6 minus x squared. This is 6 minus x squared, is right? The whole 6 minus x squared is outer radius. What's it like inner radius? This is like a center on the rotating axis. You can connect to the segment, small one. So this length is inner radius. This one, what's that? This is a function value on the blue line, 2x. Exactly 6 minus 2x. What's it like a volume? Integral from A to B. ax dx. You can use it. So integral from same 0 to 2. What's it like ax? pi times outer radius is 6 minus x squared minus inner radius 6 minus 2x. So that's it. This is exactly volume of the solid. So like this, we have it. And calculation is up to you. This is answer. The next one is the last example. Find the volume of the solid obtained by rotating the region enclosed by y equals to 2x, y equals x squared about the x equals 4. So same. You can draw the graph y equals to 2x, y equals x squared. Only difference is rotating axis, x equals 4 here. What's like a rotating axis? Vertical line. The rotating axis is vertical line. You have to use cylindrical shell. The same. You can choose X, cut, and make rectangle. You have to rotate this rectangle about X equals 4. So what happens? We have cylindrical shell. This one, cylindrical shell. Here, so like this. This one. This is like a center. This is what? Rotating axis. The rotating axis, you can find average radius. What's average radius? Here. You can connect this midpoint to rotating axis. This is here. So what's that? This length is from here to here. So what's this one? So this length is x. This is 4. We have 4 minus x. So average radius is 4 minus x. What's like a height of the cylindrical shell? Height is the length of segment, this one. So here, exactly on the blue curve, blue line, 2x. This one is on the red curve, x squared. So this length is 2x minus x squared, exactly top on line minus bottom curve. So what's like a volume? The volume is integral from A to B, the 2 pi times radius times height dx. So integral from what's A to B? The always left-hand point, right-hand point, 0 and 2, 0 to 2. The 2 pi times radius. The radius is here, 4 minus x. We have 4 minus x is radius. Height is 2x minus x squared. The calculation is up to you. So we have like this. We have a pi. This is whole idea for finding volume problem. What's like a key part? The last one is like a key part. So we have one region bounded by y equals f of x and y equal to g of x. So how can you find the volume? Depending on rotating axis. The rotating axis is horizontal line. You have to use disk or washer method. So next one is like rotating axis is vertical line. You can use the method of cylindrical shells. This is whole idea in section 5.2 and 5.3. Okay, so this is all for today's lecture. So if you have any question, so please write your question on the chatting board. If you don't have any question, you can leave this the live session. So thank you for attending my classes. So thank you. You're welcome.